Have you ever wondered how our brains can instantly recognize beauty? I mean, in literally the blink of an eye, just a fraction of a second, we can look at a face and instinctively decide if it's attractive or harmonious. Well, welcome to this explainer on the blueprint of beauty, facial anthropometry. Today, we're going to explore the hidden math and the absolute precise geometry behind those instant aesthetic judgments.
So how exactly do we pull that off? Recognizing beauty in a fraction of a second? Take a moment to consider your own instant aesthetic judgments. You don't pause to calculate angles or measure distances with a ruler when you meet someone new. Yet somehow your brain is running these incredibly complex geometric calculations entirely in the background. It turns out there is a hidden mathematics to this instinct. It's a structural blueprint that aesthetic doctors and plastic surgeons actually study rigorously to figure out what really makes a face universally harmonious.
And that brings us right to the core concept of our explainer today, anthropometry. By definition, anthropometry is the objective measurement of the size and proportions of the human body and its specific parts. In the medical world, facial anthropometry is the exact science of measuring the face to objectively analyze its surface anatomy. Basically, it takes all the subjective guesswork out of aesthetics, giving physicians a hard, quantifiable way to evaluate facial harmony both before and after treatments. Now, the way doctors actually capture these measurements has evolved incredibly over time. Historically, the whole thing started with direct measurement using manual tools like calipers. And while that's definitely effective, measuring a patient's face directly with calipers is slow, and honestly, it's highly prone to human error. Then came 2D photogrammetry, where doctors started using standardized photographs taken from very specific angles. But today, the absolute gold standard is 3D stereophotogrammetry. By stitching together multiple high-resolution images or using mobile 3D cameras, doctors can now generate these incredibly precise, fully three-dimensional topographical maps of a patient's face.
For our explainer today, we are taking a macro to micro tour of the face. First, mapping the full face, then decoding the eyes, the mathematics of noses, profiling the lips, and finally, signs meet subjectivity.
Okay, let's dive right into this with our first section, Mapping the Full Face, Global Architecture.
It is honestly fascinating how something as organic and flowing as a human face can be overlaid with a rigid mathematical grid. An aesthetically pleasing face can actually be cleanly divided into vertical thirds and horizontal fifths. The vertical thirds run from the hairline to the glabella. That's the spot right between the brows, then from the brows to the base of the nose, and finally from the nose down to the chin. Horizontally, the face is divided into 5 equal columns, where the width of one eye roughly serves as your standard unit of measurement. Just take a second to visualize your own face. How closely do you think it aligns with these specific vertical and horizontal lines?
But we really can't talk about facial architecture without bringing up a very specific, almost magical number, 1.618. You might actually know this as the golden ratio, or phi. It's this wild mathematical proportion famously found all over nature, in classical art, in architecture, and yes, it is deeply embedded right there in the human face. In facial anthropometry, the golden ratio serves as an absolutely crucial aesthetic baseline for determining ideal facial proportions.
This brilliantly illustrates exactly how that golden ratio is applied to the face in practice. Notice how the overall facial length, spanning from the top of the forehead all the way down to the chin, should ideally be 1.618 times longer than the facial width measured across the cheekbones. And this proportion just repeats itself everywhere. For example, the distance from the outer corner of the eye to the center of the lips should ideally be 1.618 times the distance from the lips to the chin. It's literally a mathematical rhythm to our anatomy.
Let's zoom in now. Section 2. Decoding the eyes, the periorbital region.
When doctors evaluate the eyes, they don't just eyeball it, pun intended. They rely on highly specific metrics, like the margin reflex distance, or MRD. MRD1 measures the distance from the light reflection right in the center of the pupil, straight up to the upper eyelid margin. This is crucial for evaluating upper eyelid drooping, which is medically known as ptosis. Contrast that with MRD2, which measures from that exact same pupil light reflection down to the lower eyelid margin. That one evaluates lower lid retraction.
So the really crucial point here is how these micro measurements relate to the spacing of the eyes across the whole face. Let's visually anchor some of the clinical jargon you might hear, like canthus, which is simply the medical term for the corner of the eye. Notice the inner and outer canthal distances. Right in the middle of all that is the interpupillary distance, or the space between the pupils. Fascinatingly, research indicates that larger interpupillary distances in women are frequently and subconsciously rated as more attractive. Crazy, right?
Moving right along to Section 3, the mathematics of noses, the central anchor.
Because the nose sits right smack in the middle of our facial grid, it heavily influences our overall perception of symmetry. To analyze it objectively, physicians calculate what's called the nasal index. The nasal index is simply the ratio of the nasal width at its base compared to the overall nasal height. What's also super interesting is that the width of the bony base of the nose is ideally about 70 to 80% of the overall nasal width. Because the nose acts as the central pillar of the face, even a slight deviation can dramatically mask or totally unmask asymmetry in the rest of your facial features.
There are actually several mathematical rules of thumb that define the structurally ideal nose. Let's fire through a few. For instance, the width of the nasal dorsum, or the bridge, should ideally match the width of the philtrum, that's that little vertical groove just above your upper lip. Additionally, the ideal tip-to-nostril ratio is widely considered to be 1:2, and when you evaluate the profile, the nasal frontal angle, which is the angle right where the forehead meets the bridge of the nose, is considered most aesthetically pleasing in males at right around 130 degrees.
Section 4. Profiling the lips, the perioral region.
When it comes to the lower face, aesthetic practitioners use these 4 striking profile lines to assess exactly how perfectly the lips protrude relative to the chin and the nose. On the far left, you have Steiner's line, which traces that really elegant S curve from the nasal tip down through the concavity of the upper lip. Then you have Rickett's E line, the Riedel plane, and Burstone's B line. Burstone's line, for example, suggests the anterior projection of the upper lip relative to the lower lip should be a ratio of 1.6 to 1, which, brings us right back to the golden ratio we discussed earlier.
And that brings us to our final stop, Section 5, Science Meets Subjectivity, the Limits of Math.
We have looked at a lot of intense math today, which really begs a massive question. Does a mathematically perfect face always equal beauty? The authors of our source material perfectly capture this tension. They state, and I quote, "An attractive or beautiful face does not mean having ideal proportions in each facial region. Beauty is an emerging reality composed of objectivity and subjectivity. The math is an incredibly useful guide, absolutely, but cultural variations and individual heritage deeply dictate true attractiveness. Rigid mathematics must always yield to the patient's unique identity. At the end of the day, an aesthetic doctor isn't just a mathematician, they have to be an artist."
Which leaves us with a final provocative thought. As we look forward, will the future of artificial intelligence combined with 3D facial scanning homogenize beauty, forcing everyone into a single, sterile mathematical standard? Or will AI actually help us better celebrate and safely enhance our beautifully subjective differences? Keep that question in mind the next time you instinctively marvel at a beautiful face. Thank you for joining me on this explainer, and I hope it gave you a fascinating new blueprint for how you see the world.